In this video, we're going to complete the KutaSoftware Infinite Pre-Calculus free worksheet evaluating limits, and this is evaluating limits at infinity. Quickly, I'll go over a few tricks and tips to help us figure out what the limit is. So let's say we're finding the limit of a function f of x. We can think of f of x in terms of some function p of x over q of x. Now from here, it's important to note the degrees of p of x and q of x. So first off, if the degree of p of x is less than q of x, then our limit as we approach infinity or negative infinity is 0. So again, this states that if the degree in the numerator is less than the degree in the denominator, as we approach infinity or negative infinity, our answer will go to 0. Next, we'll cover if the degree of p of x is greater than the degree of q of x. Then the limit as x approaches infinity is going to be either positive infinity or negative infinity, and that's dependent on the coefficients. If the coefficient of the largest degrees of p and q are both positive or both negative, remember a positive divided by a positive and a negative over a negative is positive, but if one of the coefficients of the term with the largest degree is negative and only one, then the limit will be negative infinity. And then lastly, we're going to take care of, well, let's look. We have when the degree of the numerator is less than the degree of the denominator. We have when the degree of the numerator is greater than the degree of the denominator, but what if they're equal? If the degree of p of x equals q of x, then the limit as x approaches infinity equals the coefficient of the largest degree over the coefficient of the term with the largest degree in q of x. So quickly, for example, if we've had 5x to the third over 4x to the third, because the degrees are the same, we're going to need to look at those coefficients, so the limit would be 5 over 4. So if the degree of p of x equals the degree of q of x, then the limit as x approaches infinity is going to be the coefficient of the term with the largest degree in p of x over the coefficient of the term of the largest degree in q of x. So remembering those, let's get started with number 1. In number 1, visually we can see that as x approaches positive infinity, we're going to 0 in the y. So our solution in number 1 is 0. However, if we wanted to use those tips that I showed before we started this worksheet, we can see that p of x has a degree of 1 and q of x has a degree of 2. And because the degree of p of x is less than the degree of q of x, and when I'm writing this I'm talking about the degrees, not the polynomials themselves, so because the degree of p of x is less than the degree of q of x, see that 1 is less than 2, then the limit's going to be 0 as x approaches infinity. Now looking at number 2, we do not have a fraction, but we can think of this over 1. So this degree is greater, so the degree of p of x is greater than the degree of q of x. Therefore, we're going to be approaching infinity or negative infinity. But looking at the question in number 2, x is approaching negative infinity, so we can see as we're approaching negative infinity, y is also approaching negative infinity. So our solution in number 2 is negative infinity. Now let's move on to number 3. In number 3, we're no longer given a graph, but if you'd like to see this visually, feel free to graph it. So in the case of number 3, p of x is represented by x, and q of x is represented by x plus 3. So because the degree of p of x equals the degree of q of x, both of them have a degree of 1, we're going to need to look at the coefficients of those degrees. The coefficient of x to the first is 1, and the coefficient of x to the first for q of x is also 1. So our limit is going to be 1 over 1. Remember, the coefficient of the term with the largest degree over the coefficient of the term of the largest degree, 1 over 1. That's going to be 1 for our limit in number 3. Let's move on to number 4. In number 4, we have p of x as x cubed, and q of x is 2x squared minus 2. We have a degree of 3 in the numerator, and the largest degree in the denominator is a degree of 2. So in this case, the degree of p of x is greater than q of x. And we know that when p of x is greater than q of x, we're going to be approaching either positive infinity or negative infinity, depending on the signs of the coefficient values. In x cubed, that's a positive 1 for the coefficient, and from 2x squared, that's a positive 2. And a positive over a positive is a positive. So this is approaching positive infinity. In number 5, we care about the largest degree and what that is doing. So because x to the third grows more rapidly than x squared, or x, we do not need to pay attention to either of those terms when dealing with the limit. So really, we're looking at the limit of x to the third as x approaches infinity. And again, that's because x to the third grows more rapidly and has a higher degree than the other two terms within this polynomial. And we know that as x approaches infinity, for x cubed, that we're going to be approaching infinity in the y as well. So infinity is the limit of x cubed plus x squared minus x in number 5. In number 6, same concept. Because x to the 5th grows at a quicker rate than negative 3x to the third, 3x or 1, we're looking at the limit of x to the 5th. And as that approaches infinity, our y values are also approaching infinity. So infinity is also the solution in number 6. In number 7, again, our greatest degree is the term with x to the 4th, and that's a degree of 4. Therefore, as x approaches infinity, x to the 4th also approaches infinity. But I'd like to note that if this was a negative coefficient, say negative 1 times x to the 4th, then remember we need to take that coefficient into account. So we would be approaching negative infinity if it had a negative coefficient. However, the greatest degree has a positive coefficient, and it's therefore approaching positive infinity. Now, on to number 8. You can see that we have a degree of 1 over a degree of 2. So because the degree of the numerator, p of x, is less than that of the degree of the denominator, q of x, then our limit is 0. So the limit as x approaches infinity of p of x over q of x, which is negative x plus 2 over x squared plus x plus 1, is equal to 0. Now on to our last question, the critical thinking question. In number 9 it says, give an example of a limit that goes to 4 as x goes to infinity. So we're looking at the limit of some function as x approaches infinity. So in order for this to be a number besides 0 and one that is not positive infinity or negative infinity, that means that the degree of p of x is equal to the degree of q of x. So let's say that p of x was a first degree and q of x was also a first degree. So degree of 1 for each. If p of x was a degree of 1, we could use that as x, and if q of x was a degree of 1, that could be something such as x plus 1. However, we want this limit to be a positive 4, so the coefficient of p of x over the coefficient of q of x must be equal to 4. So if we have x over x plus 1, we now need coefficient values that equal 4. So that would be something such as 4 over 1. So we'd use 4x and 1x plus 1, which is simply x plus 1. So the limit of 4x over x plus 1 as x approaches infinity is equal to 4. Let's try another example. Let's say that p of x is something such as x cubed minus 2x squared plus 5. Then q of x, we need to have a degree that's equivalent to the highest degree in p of x. So q of x needs to have a degree of x cubed and cannot have anything greater than that. So we could have q of x be x cubed minus 3. So here we have a degree of 3 for each, and because those degrees are equal, we need to look at the coefficients. Now we know that 4 over 1 is equal to 4. Another two numbers that will give us a positive 4 would be 8 and 2. So if p of x was 8 cubed minus 2x squared plus 5, and q of x was 2x cubed minus 3, we would be looking at the limit of 8x cubed over 2x cubed, and looking at those coefficients, 8 over 2 equals 4. So that's just another example. So you would rewrite that, putting p of x as the numerator and q of x as the denominator. And with that, we wrap up the Evaluating Limits at Infinity worksheet. As always, if you have any questions, feel free to leave them in the comments below, and I or one of your peers will respond as quickly as possible. Also, if you haven't already, don't forget to support me by either liking this video, subscribing to my channel, sharing the video, or becoming a patron. For more information on that, go to my website, maemap.com, maemap.com.